Right, so now we are on lesson 2 classwork, and this is page 11 of your workbook for module 1. So we're going to start with example 1, and all of the examples in this lesson, there are a couple of outcomes that you would like to focus on. The first would be that you ultimately understand that two quantities are proportional to each other when there exists a constant number, such that each measure in the first quantity multiplied by this constant gives the corresponding measure in the second quantity, and we'll show you some examples of that. The second outcome that you would like to focus on is when you identify the measures in the first quantity with x and the measure in the second quantity with y, that you recognize that the second quantity is proportional to the first quantity if y equals a constant times x, and the constant should be a positive number. Okay, so those are the outcomes. For example 1, which is pay by the ounce frozen yogurt. You can read that. I'll read it to you, or you could skip ahead if you read it already and did the work. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and this is what they found. Determine if the cost is proportional to the weight. So basically what you are seeing is the weight on the top of this table, and this is a table. It's one of the ways that we can show proportions. It's one of the tools. And then the cost is on the bottom. So if you have 12.5 ounces, it's $5. 10 ounces, it's $4. 5 ounces, it's $2. And 8 ounces, it's $3.20. So what you are ultimately seeing is you're asking, are these proportional? One way that you might figure this out is by dividing to see what the cost is per ounce, which might be one way that you want to divide to figure it out. So let's just try some of these. And I don't have a calculator with me. Let me pull it up on my phone. Okay, so if I look at the cost and I have 5 divided by 12.5 ounces, then I find the cost per ounce is 40 cents. So for this one, so it's 40 cents per ounce. Cost per ounce, and that's just by dividing. Also, if I went backwards and multiplied 40 cents times the number of ounces, then I'm getting $5. That would also work. Okay, the next one, I would divide this. You might already see that it's going to be true. 4 divided by 10, 40 cents an ounce. And the next one is 2 divided by 5, which is 40 cents an ounce. And the final one, which is $3.20 divided by 8, which is 40 cents per ounce. You might be asking, like, well, how did you know which way to divide? You were trying to find the cost per ounce. So even if you wrote it like this, you would see, oh, I have to divide the money by that number of ounces. So what this is showing is that the cost is proportional to the weight. Okay? And one of the things that I talked about at the very beginning was that if you multiply a constant times one of these, which in this case it would be if you multiply the constant times the number of ounces, so 12.5 times that 40 cents, then you get that. If you multiply 10 times 40 cents, you get that. If you multiply 5 times 0.40, you get that. And I don't know if you could see this last one, times 40 cents, you're going to get that. So what these are constants. It's the constant that you're multiplying by. Sorry, my calculator just closed. So what you're looking at then is the constant times the number of ounces is equal to the cost. And that constant is the cost per ounce. Per ounce, which is also called the unit rate. And that might be a review word for you from 6th grade. Okay, so let's go to example 2. Let's keep building on it. You see that on example 2, you have a different sort of tool available to you. In the back of a recipe book, a diagram provides easy conversions to use while cooking. And right here you see what is called a double number line. Or maybe in previous years you've called it a stacking number line. It's just 2 number lines and they're put on top of each other to show ratios. Okay, if you're comparing 2 different items like cups or ounces, or up above we had dollars and ounces, 2 different types of units, then that is a ratio. So we're comparing ratios. And so what we can analyze is that cups, if you have 0 cups, it's 0 ounces. Well, that makes sense. If you have a half a cup, it is equal to 4 ounces. If you have 1 cup, it is equal to 8 ounces. 1½ cup, it is equal to 12 ounces. And 2 cups, it is equal to 16. So what we're looking here is, we are looking at ounces to cups. Right? Because the ounces, and we're trying to see if it is proportional or if it is not proportional here. Okay, and so ounces to cups, you can use a calculator to figure this out, because this is not just a calculation. I could just put in the ounces, but I'd rather you see it. So let's see, 4 divided by a half, and a half is equal to 0.5, so that's 8. Eight ounces per cup, right? And you could do that here. 8 divided by 1 is 8 ounces per cup. And then 12 divided by 1.5, which is 8 ounces per cup. And then 16 divided by 2, 8 ounces per cup. Okay, so the ounces are, I don't know if you'd say is or are proportional. I think either would work. To the cups. Okay, it is a conversion, so it should be correct, especially if it's in a recipe book. You don't want your recipes to end up tasting nasty. Okay, so we're going to go on to exercise 1. This is where I'll stop the first video, but let's look at it first. So exercise 1 is during Jose's physical education class today. Students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. So you have a double number line and you have time and the calories burned. 0, 0. 1 minute you burn 11 calories, 2 minutes 22, 3 33, 4 44. And is the number of calories proportional to the time in this case? Are all of those equal? So you're looking at calories per time. And then it's asking you to do an example. If you jumped rope for 6.5 minutes, how many calories? So you'll be doing something up here like 6.5 minutes. Okay, So what? I'm going to stop this video. It's a little long, so it'll take a while to upload. Once you do this activity, and the solution will be on the next video as well as more.